Right now we're going to be working on the process that we take rough sawn lumber to the point where we can actually use it in a project. Now a lot of people go to Home Depot or to the lumber yard and they're going to buy material that's already been surfaced, meaning that once it's been sawn out of the tree, the manufacturers put a smooth face on the board and usually a straight edge on the board. This is what you call nominal width and thickness lumber, and that's your standard 1x2, 1x3, 1x4, etc. You get 2x4s, 2x6s, 2x8s. In boat building and in a lot of cabinet making or fine woodworking, you don't get all your lumber S4S or surfaced on four sides like you do at the lumber yard. We buy it from a sawmill, and it's not exactly surfaced. So what we've got here is a rough surface that a lot of times is rough on all four faces, and the edges aren't always straight and the faces aren't always flat. So we're going to go through that machining process, or at least the beginning of the machining process, to make sure that the lumber is usable. Because once we pass the material through a machine like this, and then the thickness planer, then we can take it to the table saw and rip it into straight parallel pieces, or the chop saw and cut it into shorter lengths. So the first step in the joining process is to inspect your material. What you want to do is see if you have a flat face and a straight edge so that you can mill the material on some of the other machines like the table saw. So you do a visual inspection of the material first. What you want to watch out for is boards that are extremely twisted along the faces, or they have a lot of crook along the edges. Now if you sight down the edge of this board, you can see that you've got some crook in it. In other words, the board has got some shape in this direction. Okay? Now that's easy to determine by looking down it with your eye, or you can put it on a flat surface, and if you see any gaps, you know that the edge of that board isn't really straight. Okay, on this edge we've got a concave surface, and on this edge we've got a convex surface, because it's not touching on the ends. Now to determine if the board is flat in plane or not, we can put it on a flat surface like that and try and rock the corners. Okay? If it doesn't rock, you know you've got a fairly flat board, so you don't have to worry too much about it. So what we're going to do right now is try and eliminate some of the crook that's in one edge of this board, so that then we'll have a straight edge that we can put up against the table saw so we can rip parallel boards out of it. So I'm going to get my rough stock out of the way. Now, safe tool operation, any tool operation, whether it's a power tool or a non-powered tool, requires the operator's complete focus and attention. So that means that you don't want to be joking around while you're doing it. You don't want to be thinking about lunch. You want to be thinking about the work that you're actually doing. And we're going to be working on the edge and face joiner today. This tool consists of course, the ever-present guard, okay, that we can swing out of the way. And then the business part of the machine, we've got a cutter head here that's got a set of knives in it. So if I rotate this, okay, you see we've got a knife here, we've got a knife here, we've got a knife here. This particular cutter head, when we move this fence back in that direction, we can do a board that's 12 inches wide. Okay? Right now we only have to do an edge that's about 3/4 of an inch thick. So we don't have to have a lot of surface here. I've moved the fence over here where we've got a nice clean blade edge to work with. This cutter head rotates in a clockwise direction, so it's rotating in this direction. The operator stands facing the rotation of the blade. Most of our power tools, when we feed our material into it, we're always pushing the material against the rotation of the blade, whether it's the table saw, the joiner, the thickness planer, or a router. And the reason being is that you got a lot more control if you're pushing against the force. If you were pushing in this direction and the cutter head's rotating in that direction, you just take it and zip it out of your hands just like that. So on this tool we've got, of course, the cutter head and the guard. This is the in-feed table here. This is the out-feed table here. and this is the fence. And the fence is always set up at 90 degrees to the table. That's because we want to try and machine a square edge onto the flat face of the board. So we've got a flat face, and then the edge of it's going to be square. And we're going to be using our ever-present combination square to check for square on the edges and the faces of these boards. Okay, so I'm putting that over there. So the way this tool works is that as the material passes over the cutter head, of course the knives are going to shave some material off, and you wanted to be able to determine how much of a cut you're going to take. On this particular tool, we don't have a gauge with numbers on it like a lot of the tools. The way we determine the depth of cut is by looking at the fence and the relationship between the outfeed table, where it's completely tight against the outfeed table, and the infeed table. You can adjust the infeed table up and down to adjust the depth of cut. Okay, you can see here I'm going to open this way up so you can see it. Okay, so if I took my piece of material here and passed it from the infeed table over the cutter head to the outfeed table, it would try and remove about that much material there. We're looking like about 1/4 of an inch. Now you hardly ever want to remove that much material at a time. For one thing, it pushes the tool too hard. For the other thing, it makes it very hard to control your work because that 3 or 4 horsepower motor is trying to shove that material back at you. So about the maximum depth of cut we ever want to take is about 1/16 of an inch. Okay, in some cases we're going to take an even lighter cut to make things easier on ourselves, the material, and the tool. Okay, so we've got it closed down there. We're going to take about 1/16 of an inch cut. Now I will demonstrate a deeper cut, but we're going to start out with a really light pass. So if we pass the material from the infeed table, holding it tight up against the fence, over the cutter head and onto the outfeed table, that's going to give us the edge that we're looking for. Okay? Now you always want to work in a safe and sane manner, and just as when we're working on any power tool and we've got this big machine going and it's distracting us, we want to make sure that the area is clear of obstacles. Okay? So I don't have any debris on the ground that I can trip over, and there's nobody back there in the line of fire in case I lose the board and it shoots back. Okay? So the first thing we're going to do is put on our safety glasses. Okay? And then we're going to open the dust collection chute. As the cutter shaves pieces off the board, it gets sucked down below the tool, up the vent, and I've opened the dust collection gate right there, and it's going to get sucked up through the ceiling into a hopper. You check your board for twist or crook. Okay? You determine which is the concave side of the board. You want to put the concave side down to cut the lower legs off, so that as you cut the leading edge off, it feeds onto the off-feed table in a flat manner. Okay? You check your work area for obstacles. Make sure there's nobody in the line of fire in case you get a kickback. And then you're ready to go. If you have a long piece that you're working with, you're going to want to recruit a helper. We're working with short pieces for demonstration here, so we don't have to worry about it. So we'll turn the machine on. You always want to place your work firmly up against the fence and down against the table. So my left hand is going to apply pressure to the work down against the table, up against the fence. My right hand is going to be feeding. We still got a ways to go, so we're going to take another pass. Okay, now checking my work, I can see that I've still got a gap here. If I'm not sure, I can always eyeball the edge of the board, see if I've got a straight edge yet. We're not there. Again, whenever we're working on any of the large power tools that have a table and a fence, those are the references that you're working against. So you always want to hold your work firmly down against the table and up against the fence. And that's a really important point, because those are the control surfaces. If you were just freehanding this and you didn't have a fence to work against, you wouldn't be able to square up the edge of the board. You might be rocking as you go through. And of course, if you didn't have a table, it'd just be the cutter head that you're trying to pass this over with no references. So when we put the material down, we make sure the concave side is down. Our left hand's pushing down against the table and up against the fence, and our right hand is feeding. As we start the cut and pass it over the cutter head, all the pressure's on this infeed table. My left hand, if I've got a firm hold on the work, my hands aren't like this so they can't slip down into the cutter head. Okay? We're up on top. I know I'm not going to slip down into the blade. I got the guard there. Okay? I start feeding over the cutter head. My left hand follows the work, and the pressure goes onto the outfeed table with my left hand. As I get about halfway through the piece, I want to switch all the pressure to the outfeed table, because now I've got this long, flat reference surface, and I want to get the tail end of the board jointed off. So you follow right on through like that. Okay? So that puts a nice straight edge on this board. We can always put that in the table saw and rip off as many straight edges as we want. A lot of times, as trees are growing, tension grows into the tree. Okay, so a tree might be growing up out of the ground, the wind's blowing, so that tree's leaning over for its whole life. You cut it down, they take it to the sawmill, and that tree is stronger on one side than it is on the other, and some of that tension gets released and your board starts twisting. So that's one of the reasons we have to go through these milling procedures in order to get that twist or the crook out of the edge of the board. Okay, this is the one we were looking at a little earlier. This has got fuzzy edges on it from going through the rough milling procedure. They sawed this square board out of a round log, and it looks fairly square. So we've got our safety glasses on, our dust collector's open. We're going to check for crook or for twist. I can see that's rocking just a little bit. So the first thing I want to do is face join this board so that I've got a nice flat surface that I can put up against the fence when I go to edge join it. So here we go. Now when we're face joining, we're covering a lot more surface than when we're edge joining, so we want to take a much lighter cut, and we want to take it easy with our cut. So I'm going to close the cut down just a little bit, so we're just barely touching that board. Now you got to be careful when you're passing your hands over the cutter that you're not going to be able to slip down into the cutter head. You always want to be aware of where your hands are and the hold you have on the board. And if that board takes off on you, you just get your hands out of the way. Don't try and save the board. Safety glasses on, dust collector, clear for obstacles, make sure there's nobody around that can get hit by flying boards. Okay, turn the machine on and start your first light pass. Pressure on the left hand. Pressure with the right hand on the outfeed table. Okay? You might be able to see we've surfaced this much area, but we've missed this. It shows you that that board wasn't completely flat when it started. So we're going to take another pass. We don't want to be able to see any daylight underneath the blade of the combination square. You can see a little daylight on this hand, on your left side there, I believe it is. Okay? So what we're going to do is square this edge up to this face now. Now, assuming the fence is set square to the table, when we pass this material over the joiner, we should come up with an edge that's square to the face. only hit some of the board here, some of the edge. We've got a lot more to clean up. There was a little bit of crook in this board too, because you can see it's not cutting in the middle now. Okay, we've taken a cut along the whole surface. It's looking pretty good. And we've got no daylight. Okay, so you can see that this tool is really useful for squaring those pieces of wood up. Now the next step in the milling process, once you're done squaring up a face and an edge, we plane the face, we've squared the edge up to it. If we wanted to make this into an absolutely square or rectangular piece of material, we could take it to the table saw next and rip a piece off, but we'd like to make sure that it's completely parallel on both faces. Okay? Now we could joint the other edge of the board, but it's not guaranteeing that those edges are going to be parallel. That's the table saw's job. To make the faces parallel, we're going to use the thickness planer.